Hello, good evening everyone. Welcome to BYJU'S exam prep. So I hope that you are doing good. And yesterday's session was actually cancelled because of the power cut. Yes, so the video and audio is absolutely fine. So quickly share this session with all of your friends. Come on. Hello Reshma, good evening. So guys, quickly share the session with all of your friends. Yes, everyone. Share the session in the Telegram channels also, na? In the Telegram groups also you can share the session because here also we have the friends and we can call them up in the session. Yes. So yesterday the session could not be complete due to the power cut, and today we are continuing that session. So I think the students have joined. So before starting the session, I want to tell you that this is the Sakit Verma, and I have done MTech from IIT Guwahati, and I'm having more than 13-year experience. And these are the subjects that I usually teach. And you can take the benefit of this in these subjects from my side and in your preparation journey. Okay, because in this subjects especially, I have the expertise in the last 13 years, so I can guide you that which topic and which concepts are important and how to solve the questions. Okay, and quickly like the session also, and you can join my Telegram group as well. In the Telegram group, you will get the updated link whenever the sessions will be conducted. The link will be given to you whether it is an app session or it is a YouTube session. Okay, and you will also get the PDF of the different classes, and also your doubts will be cleared by the experts. And the latest information about the exams will also be shared in this particular group. And one more thing that you should know about the scholarship test. That is, if you are preparing for GATE and you want to prepare for GATE 25, suppose, and you want to complete want to finish the course completely with us, entire syllabus of GATE, then you can take the scholarship test. And if you take the scholarship test, you may avail the 90% discount in the overall course fees, and it will end up to the 10,000, 5,000 rupees only. So it is a best opportunity for you to get the scholarship test, and every Sunday we are providing this. So by chance, if you this week you don't perform, then you can perform in the next week also, and you can avail up to 90%. At least 20-30% you will definitely get in the first week itself. But yes, if you perform well in the scholarship test, you may avail up to 50%. Then if you suppose download the app, the link is given in the description. If you suppose download the BYJU'S exam prep app, so in the app you get the 20 free lectures. The 20 free lectures you can directly watch from any of this paid course, free sessions, recorded course. So you can watch any 20 lectures for free. And after that, the free sessions will be there, but the paid sessions will be logged. So from the paid session also you can watch 20 lectures. So at least if you suppose have any doubt in the communication and you want to study it with me from me, then you can watch that particular lecture from my side, which is available in the pet course. Okay, so because yesterday the at this point of time we got stuck, so I'm starting from here only. So this is the timer that I am running for you. Solve this question. This was the question where we stuck yesterday. And like the session, okay? Like the session, share the session. A uniform plane wave. The question from the uniform plane wave. So I think this is the most easiest part of the EMFT uniform plane wave. Very interesting also, and the vast subject, vast syllabus. This chapter has number of topics. Quickly share your answer. Now, last 1 minute left. What is the right answer for this question? Hello, Dreamer. Good evening. After long time. So you are getting option A, which is the incorrect one. Option A is not the right answer. Prince also getting A. It is also not the right answer. See, uniform plane wave, 25 volt per meter. Electric field is normally incident on the infinite thick slab of a material of a dielectric constant 5. The electric field just inside the slab interface. Just inside. So just inside means it is not traveling in the dielectric slab. So it is coming from the air and it is going into the dielectric having the dielectric constant. Just wait a second, guys, for 1 minute. Yes, so at boundary, you are saying yes, at boundary we want to calculate. So, see, first of all, you have to calculate that how much part is transmitted. So, for that, we need a transmission coefficient, and transmission coefficient is 2 eta 2 divided by eta 2 plus eta 1. Okay, so eta 2 we calculate because it is in the dielectric medium. So 120 pi divided by root 5, right? And eta 1 is, we will consider air. So this is 120 pi. So now if I put that values, so this is 2 into 120 pi divided by root 5, and here it is 120 upon root pi plus 120. So this 120 will get cancelled and we will get 2 upon root 5 divided by 1 upon root 5 plus 1. Okay, so finally we will get 2 upon 1 plus root 5. 2 upon 1 plus root 5. Okay, and after calculation, this what you are getting? Can anybody tell? Yes, it is 0.618. So the value you are getting is 0.618. Now, how much part is transmitted? So that is given by ET naught divided by EI naught is equal to the transmission coefficient. So ET naught, we want to calculate the electric field just inside the dielectric slab, means that much part is transmitted. So it is tau into EI0, and tau is 0.618, EI is 25. So after multiplying this, you are getting 15.45. So 15.45 is the right answer. Understood, Prince? Yes. Yes. Perfect. Now you have understood. Now answer this one. Just answer this question. In a conductor, electromagnetic waves are given. Okay, the question is, in a conductor, the electromagnetic wave with conductivity is given, depth is given, the wavelength we want to calculate. We have to calculate frequency first, yes. Now tell me the answer. I am giving you 2 more minutes to solve this problem. First of all, you have to think of the frequency, because if you want to calculate the wavelength, so lambda is equal to C upon F. Okay, the lambda is equal to C upon F. So how will you reach to the frequency? Think of calculating the frequency. I am giving you 2 more minutes. In a conductor, the electromagnetic wave with the conductivity penetrates to a depth of 10 micrometer. Come on, Prince. Have you got the answer? So skin depth is delta, which is given as 1 upon root over pi f mu sigma. And this delta is given, which is 10, and 1 upon root over pi f we want to calculate. Mu is 4 pi into 10 to the power minus 7 into sigma. What is the value of sigma? यस, फ्रैक्शन के फॉर्म में आ रहा है. हाँ बताओ तो, फ्रैक्शन के फॉर्म में कितना आ रहा है? एफ कितना आएगा यहाँ से? सिग्मा, सिग्मा की वैल्यू 54 है. तो 54 है, तो यहाँ से पहले फ्रीक्वेंसी की वैल्यू बताओ कितनी आ रही है फ्रैक्शन में? कितना? 46.9 इंटू 10 to the power 12. 46.9 इंटू 10 to the power 12 हर्ट्ज, ये आना चाहिए आपका. ठीक है. फिर इसके बाद हम कैलकुलेट कर लेंगे लैम्डा. यहाँ से 3 इंटू 10 to the power 8 डिवाइडेड बाय 46.9 into 10 to the power 12. So after dividing this, you will get 6.9 micrometer. 6.9. ऑप्शन डी. ऑप्शन डी आ रहा होगा. ठीक है, देख लो कोई कैलकुलेशन में कोई दिक्कत तो नहीं. ठीक है, चलो इस क्वेश्चन को सॉल्व करो. Yes, there is a batch available for the Gate 24 from now. That is a crash course available in the BYJU'S exam prep app. The link is given in the description, Shri Krishna. So you can try, and the contact number is also given in the description. So you can contact them and discuss that what are the courses running and what are the courses available for the Gate 24. And you can download the BYJU'S app also in the link. The link is given in the description. Okay, so just download it. You can watch the 20 free lectures. Okay, so the 20 free lectures also available from the paid course. So you can get an idea that what are the different faculties going to teach you. Yes, group velocity. What is group velocity? How do you define the group velocity and the phase velocity? How do you define the Phase velocity, Prince. Yes. So now the group velocity is the differentiation of beta with respect to omega, or just vice versa actually. Differentiation of omega with respect to beta. See, so first of all, I am writing here the definitions. So the phase velocity is given by omega by beta, no doubt about it. And the group velocity is given by del omega by del beta. Okay, so we have to find this ratio of this. Okay, now let's calculate the group velocity because the phase velocity is direct. So this is the omega mu sigma divided by 2. Let's differentiate with respect to omega. So the differentiation is 1 upon 2 omega mu sigma by 2 to the power 1 by 2 minus 1. Okay. And this is mu sigma upon 2. Now if I solve it, delta beta divided by delta omega, this is minus 1 by 2, right? So it is inverse, you can write omega mu sigma upon 2 to the power minus 1 by 2 and mu sigma divided by 2. Clear? And what about this is your group velocity, delta omega by beta. Okay, wait. This is delta beta upon omega. So if I write just inverse of it. So let's take the delta omega divided by delta beta. Then it would be uh, 4 upon root over omega mu sigma divided by 2 and mu sigma. Okay, so this is your group velocity. Now what is the phase velocity? The phase velocity is omega by beta. So Vp is equal to omega by beta, which is omega by root over omega mu sigma by 2. Now if I take the ratio, what is the ratio we want to calculate? The ratio of uh, group to phase, group to phase. So Vg upon Vp. So Vg is 4 upon root over omega mu sigma divided by 2 into 1 upon mu sigma into Vp. Vp is omega divided by root over omega mu sigma divided by 2. So it will get cancelled and we are getting 4 upon mu sigma omega. Okay, 4 upon mu sigma omega only we are getting. So I think mu sigma Vp is equal to what is left here. Actually, we should get cancel out all these terms. Omega by beta. Mhm. Why we are not getting it? If I take it inside, this will get cancelled and omega is left. What is the mistake here? Just calculation we are left with, but we are missing one terms. Why? Because mu sigma is extra coming, and why here is we are not getting. Omega is there, but mu sigma. Wait, let's do it in this way. Wait a second, guys. Let's solve this in the different way. Let's take this mu sigma inside. So if I take this mu sigma inside, let's see what happens. 1 upon 2 is there. Okay. And this is root over omega mu sigma and divided by 2. And if I take it inside, so mu is square, sigma is square divided by 2. 4 in fact. Na? So 4 we will get. And from here we will get 1 upon 2. This mu will get cancelled and this sigma will get cancelled. So we will get 2 mu sigma upon this 4 omega. So yes, let me write it 4 omega. And we will get 1 upon 2 root over mu sigma upon 2 omega. Mu sigma upon 2 omega 1 upon 2. Okay. So this is del beta upon del omega we are getting. And this is nothing but a del omega by del beta, right? And it is 1 upon group velocity. So group velocity, as I said, del omega upon del beta. So 1 upon 2 root over mu sigma upon 2 omega. Inverse of it. 2 into root over 2 omega upon mu sigma. This is our first equation. Now we want to calculate Vp. Vp is omega upon beta. So omega, I think root over omega mu sigma upon 2. And when I will write it, it is 2 omega square upon omega mu sigma. And we can write 2 omega upon mu sigma. Yes, so why we are not getting in that way? Vg upon Vp. So here we will calculate Vg is 2 times root over 2 omega by mu sigma and Vp is root over 2 omega by mu sigma. So this will get cancelled and we will get 2. So the answer is 2. So correct answer we are getting 2. I don't know, means there is some mistake in the calculation there. But yes, now we have got this. Okay. Now try to solve this. Next question. So last 1.5 minutes. Just outside a train compartment, the field strength of a radio station is 0.5 volt per meter. Assume the compartment to be a closed box of a metal having a conductivity 3 into 10 to the power 6. Siemens per meter, then thickness is 2 millimeter, and the frequency of the radio station is 400 kilohertz. So what will be the field strength? 6.44. Yes, that's the right answer. That is the right one. So first answer I have got from the prince, 6.44 millivolt per meter. Correct. So what we have to do, because there is a conductor, and in the conductor there will be some loss, and because it is a good conductor, so if there is a good conductor there will be some loss, and because of that loss we can calculate the attenuation, and first of all we have to calculate the attenuation constant. So this is pi f mu sigma, and which is equal to pi into f 400 kilohertz into mu, that is 4 pi into 10 to the power minus 7 into sigma, which is 3 into 10 to the power 6. So after calculating this, how much you are getting alpha? Alpha is 2.176. 2.176 into 10 to the power 3 Napier per meter, and the electric field strength at 2 millimeter, as it has traveled 2 millimeter. So this is E naught e to the power minus alpha into 2 millimeter. Okay, so that is E naught. How much was the strength? So initially the strength was 0.5, and e to the power minus 2.176 into 10 to the power 3 into 2 into 10 to the power minus 3. So you will get 0.5 e to the power minus 2.176 into 2, which is 6.44 millivolt per meter, as per the calculation. The prince has given this answer, so I am taking into consideration, and the answer is 6.444. Right. Now answer this one. Yes, you have 2 minutes. Oh, one minute left. Have you got the answer, prince? Anyone? Last 30 seconds. If you need more time, then also, I can give you if you need more time. Okay, so I'm giving you 2 more minutes to solve this problem. Inside a rectangular waveguide for a particular mode, the phase velocity is 3 times of the group velocity. Phase velocity is 3 times of the group velocity. So last 1 minute. Anyone? Inside a rectangular waveguide for a particular mode, the mode is not given. The phase velocity is 3 times the group velocity at 5 gigahertz. Okay, so let's discuss this problem. See, here it is saying that the phase velocity is 3 times of the group velocity. Okay, VGZ. VPZ is equal to. And we know that, okay, we know this relation. We know that VPZ into VGZ is equal to C square. Okay, so VPZ is equal to 3 times VGZ. So VPZ is here VPZ divided by 3 equal to what? C square. So from here you can say that the VP is 3 times of C square, or you can say the VP is root over 3 times of C. Now what is the formula for the phase velocity inside the waveguide? It is C upon root over 1 minus Fc upon F whole square. VPZ we have calculated as root 3 into C. Okay, root 3 into C. This is also C. So root over 1 minus Fc upon F whole square. This C and C will get cancelled. When we square it, we will get 3. 1 minus Fc upon F whole square. Okay, 3 into 1 minus Fc upon F whole square equal to 1. So, we can say that 1 by 3 equal to 1 minus Fc upon F whole square. So Fc upon F whole square is 1 minus 1 by 3, that is equal to 2 by 3. So from finally we will get Fc equal to root over 2 by 3 into F. What is F? 5 gigahertz. So let's calculate. Root over 2 by 3 into 5. 4.08. 4.082. So it is 4.082 gigahertz. Answer is 4.082. Got it? Okay, just you need to put the value of f, which is 5, and you will get the answer. Good question. Simple, but it takes time. And you guys take time to solve this, right? Now answer this one. Both the mediums are non-magnetic as well as lossless. Last 1.5 minute, friends, and the other students, quickly, guys, answer this question. All are the new questions that you might have not seen before. A uniform plane wave in region 1 is incident on the planar boundary separating the region 1 and 2, considering the medium to be a non-conducting non-magnetic medium, sigma 1 and sigma 2 are 0. The ratio of the first to the second permittivity is 8.21. Then the energy transmitted to the region 2 is. So here we know that because both the mediums are non-magnetic in nature and the lossless also because the sigma is 0. So we know that the intrinsic impedance is given by 120 pi root over mu r divided by epsilon r for the lossless dielectric. And because it is non-magnetic also, so for non-magnetic mu r is 1, so this is 120 pi root over epsilon r. This is the value of intrinsic impedance. Now we will use this. Eta 2 for the second medium will be 120 pi divided by root over epsilon r2, and eta 1 would be 120 pi divided by root over epsilon r1. The reflection coefficient is eta 2 minus eta 1 divided by eta 2 plus eta 1. So this is 120 pi divided by root over epsilon r2 minus 120 pi divided by root over epsilon r1 whole divided by 120 pi divided by root over epsilon r2 plus 120 pi root over epsilon r1. Okay, so this is the root over epsilon r1 divided by epsilon r2 minus 1 divided by root over epsilon r1 divided by epsilon r2 plus 1. So here it is the 0.821 is given this ratio. So root over 0.8, 8.21 in fact, 8.21. So this is 8.21 minus 1 divided by 8.21 plus 1. This is your value of gamma. So calculate it. What is the value of this gamma? The value of this gamma is 0.482. Okay, so you are getting 0.482. Now the percentage which is transmitted, it is asking for the transmitted. This is the percentage which is reflected. So percentage that is transmitted, percentage of input power that is transmitted is 1 minus mod gamma square. If you want to calculate in percent, then multiply it with 100. So this is 1 minus 0.482 whole square and then multiply it with the 100. So when you will calculate it, how much we are getting? 0.233, 76.71. 76.71%. Check this. 1 minus 0.482 square. Yes, 76.76. 76.76%. This is what we are getting. Now answer this next question. Okay. So a rectangular waveguide operates in the dominant mode. It is asking for the dominant mode cutoff frequency is filled with the dielectric. We want to calculate the cutoff frequency is 8.5 and it is filled in the dielectric. So we know that the cutoff frequency is given by Vp upon 2 root over m by a whole square plus n by b whole square. Cutoff frequency cutoff frequency is 8.5 into 10 to the power 9. Vp is C upon, that is 3 into 10 to the power 10 upon root over 1.44 into 2, and because it is dominant mode, so dominant mode means TE10. So TE10 means m equal to 1, n equal to 0. So we will put this, so we will get 1 upon a only. So from here you will get, so it is 17 into 10 to the power 9 into root over 1.4 into a equal to 3 into 10 to the power 9, 10. So we will cancel it, we will get 30. So a is equal to 30 upon 17 root 1.44. So 17 root 1.44 we are getting 1.47, it should come 1.47 as per your calculation, right? - 1.4. This is the final answer. Okay. Now moving forward for this question. Okay, let's solve this one. That question I left for tomorrow. The previous question I will discuss tomorrow. So I'm giving you one easy question because I'm not getting the response from you guys. So I think you are not able to solve. A ray of light traveling through glass with an index of refraction n equal to 1.48 strikes the interface of glass water If epsilon r is equal to 1.76 for the water, then the minimum angle so that the ray does not enter the water. It should not enter into the water. It should not enter into the water. Yes, last 1 second. Anyone got the answer? No? Okay. So in this question, we don't want the ray to enter. So for which angle the ray will enter, the angle is known as critical angle. So the critical angle is sine inverse the second video refractive index divided by first video refractive index, and the refractive index is directly proportional to the root of permittivity of that medium. So the ray is traveling through glass with an refractive index 1.48 and strikes the interface of the glass water if the this is the 1.76. So for one, it is given as the refractive index, so we have to use root over 1.76, and here it is 1.48. So what is the angle here? Let's see. Okay, for one we are using the refractive index and one we are using the permittivity, like this we are writing. Okay, I will write it here. So epsilon R2 we are using, and N1 because N1 is given. So 1.76. So we are getting shift sine inverse root over fraction, then root over 1.76, 1.48, 63.68. So this is the angle beyond which the ray will transmit, and below that the ray will not transmit. So answer will be 63.68. Okay, answer would be 63.68. Okay, guys, so I hope that you have enjoyed this session. Thank you for watching this session, and I would like to tell you that we have the paid course also for the Gate 24 crash course. And if you want to prepare for the Gate 24 in the next 3 months, then you can prepare with us. And this is my Telegram group. And don't forget to subscribe this channel, and also stay tuned with us in the BYJU'S Exam Prep app you can download from the link given in the description, where you get the free sessions and along with that the 20 lectures from the paid courses as well. Thank you.